if in the index position I have a difference of two squares, but in this form here, where the second term involves a constant, not the first, like my last example, then I think I'm going to commit to this particular substitution. And let me illustrate with an example in my usual fashion. So it looks to me like this difference of two squares is indeed like the binomial you saw on the other side, where a is equal to square root of 3. Consequently, I'll commit to the substitution. I'll pay the consequence of my actions. Now, jeepers, paying the consequence of this substitution. Here's what I have. Unlike my first example, let me walk a little faster. 3 gets pulled out, becomes a root 3 on the outside of the radical, cancels. That leaves me with, oh, by the way, that was squared, wasn't it? So I think that's going to leave me with this. However, using my second Pythagorean identity, doesn't that tell me that these two terms are equivalent to the single term? And of course, yet again, the square root of the square of that thing appears to cancel out, but it doesn't. I should have absolute value bars here. But yet again, like what I showed you with the sign substitution, if you look at the restricted domain of the tangent function, I should say of the secant function, then you realize tangent in the first and third quadrants when it comes to its inverse are always positive. So I can suppress the absolute values, thank goodness. If I couldn't, I think that'd be a bit of work. Next. Well, like I said, I canceled those 2 root 3s, so that one's gone. I can cancel these two, and I can cancel a single factor secant of theta upstairs and downstairs. And I think that's going to leave me with this. Or how about this? But you and I know how to handle that kind of trigonometric integral. So let's do what we've already done in the past. As we all recall so darn clearly, another name for that single factor is this multi-term expression via my first Pythagorean identity. Now that I've anti-differentiated term by term, I will merely come in and back substitute with this relationship. I cleaned up a little bit. Now that I've gone back and back substituted with that relationship that I'm now erasing, let's you and I just take this one step further and back substitute to the original relationship I had between x and beta. So let's look at this relationship. Doesn't it say this? Pictorially, doesn't that say this? Pythagorean theorem tells me this. Again, notice I saw that somewhere in the original integrand. Next on my list, I do think the sine of that angle theta here is this over this. What do you think? One more touch-up of cleaning? Well, here too, like my last example, I don't think I can do anything to clean that final expression up further. I'm happy. I hope you are.